The differentiation of f of x is equal to a to the x. If y is equal to f of x, then we know that dy by dx, f dash of x, will be the limit as h goes to 0 of f of x plus h minus f of x over h. Let f of x be equal to a to the x. Then f dash of x will be the limit as h goes to 0 of x to the x plus h minus a to the x plus h minus a to the x over h as h goes to 0. Using one of the rules of indices here, we can rewrite this as the limit as h goes to 0 of a to the x times a to the h minus a to the x over h. We can do this because a to the m plus n equals a to the m times a to the n. So we've done sort of applied that rule there. Okay, because a to the x is not part of the limit, because it's only when h goes to 0, we can take that out. So we're going to have a to the x as the limit as h goes to 0 of a to the h minus 1 over h. Now, if we look at this, if we can find a value of a, so when we make h very, 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 very small, that all of this is equal to 1, then when you differentiate the original function, you will end up with itself. So this implies there is some value of a, for which a to the h minus 1 over h is equal to 1 as h goes to 0. And therefore, if we can find this value, then d dx of a to the x is equal to a to the x. So, if you differentiate a to x for this particular value of a, you will get the same function, which makes life really easy for us. Let's just have a look at this more closely using a graph. This is made with a program called GeoGebra. Okay, here I have the function of f of x is equal to 1 to the x, which is a straight line because 1 to any power will be equal to 1. Now the gradient of this line will be y is equal to 0. The gradient function will be y is equal to 0. So I'm just going to click the box there, and you can see a red dotted line appear, and this gives me the gradient function. Now if I change values of a using the slider here, okay, so I'm getting like a bit more like an exponential function. Underneath we can see that the gradient function is changing. Okay, and if we move this around, which I'd ask you to stop the video and try to do that. Okay, so I'm just going to move mine around, carry on moving it. Okay, we can see that for some value here, they will coincide, which means that a to the h minus 1 over h is approaching to 1 for a particular value. Now, that particular value is approximately 2.71. Okay, we can see that they're actually coinciding here. Okay, so what we're saying here, if we differentiate this value of 2.71 to the power of x, you will get 2.71 to the power of x. There's a screenshot of what I've just done. So what I'm saying, the limit as h goes to 0 of a to the h minus 1 over h is going to be the limit with 2.71 and a bit more to the power of h minus 1 divided by h. If you put that into your calculator using a value of h very small, something like 0.000001, you will see that this will approach 1, not 0. And as this approaches 1, this number is actually called E, where E is equal to 2.710134 45596, but carries on and never recurs. So it's an irrational number. It's a bit like the number of pi. Okay, and it never recurs. And we've come across it before when we did logs and log functions. Okay, so what we're saying here, the conclusion is that dx, we will let this number be called e, of e to the x is equal to e to the x. So if you differentiate the function, the gradient function will be exactly the same.